Hello students. So hopefully you tried to do these two problems on your own, and I'm going to come back and explain them because I do think it's really important for us to talk about angles in quadrants 3 and 4 and what we see on our calculator versus what we need to just use our minds and logic for. So I've plotted my point -2, -1, so I know that's in quadrant 3. That means I also know that my angle is going to be between pi and 3 pi over 2. And I know it's going to be in radians, so I might want to think to myself, this is 3.14, and maybe you don't know that one off the top of your head, so we can come in and look at it. And I'm just going to go to the handheld only. So 3 pi over 2, and I'm going to control enter that and get it's about 4.7. So I'm looking for an angle between 3.14 and 4.7 radians. All right, so doing my Pythagorean theorem, I can figure out this positive value. So remember, this is going to be -1, this is -2, but this length is positive and it's going to be √5 using Pythagorean theorem. So sine of my theta is going to be -1 over √5. Cosine of theta, -2 over √5. Tan of theta is going to be positive because -1 divided by -2 is 1/2. So now let's come into our calculator and see what happens. If I do sine inverse of -1 over √5, then it's giving me -0.46. So let's think about where that is. That -0.46 is a negative angle, so measuring this direction. And 0.46, well, that's definitely less than a full, that's less than pi over 2 radians, so it's up here. So let's go back to our idea about our reference angle. Our reference angle, we always say, is a positive acute angle between our terminal side and the nearest x-axis. So if I go back and just think about doing the sine inverse sine with the ratio, the positive ratio, I get the positive angle, so that's my reference angle. So theta prime, or my reference angle, is 0.46 radians. So I know the theta that I want is going to be pi plus theta prime, because it's all of pi plus that reference angle. So I'm going to say plus pi. And I get 3.61 if I'm going to round to the nearest tenth, which is what I wanted, between 3.14 and 4.7. So approximately 3.61 radians. So I think it's always best to just do your arc sine, arc cosine, whatever, with the positive ratio to find your reference angle, and then think about how your reference angle can be found in the quadrant you want to be in. So for example here, I've got +4, 25 and 16 is 41, so that's going to be square root of 41. So starting with sine, root 41. So sine value is going to be -5 over root 41. Cosine value, 4 over root 41. Tangent is going to be negative because I have -5 over +4. And now my theta is going to be between 3 pi over 2 and 2 pi if I'm finding the positive angle, or it's going to be between 0 and -pi over 2 if I'm finding the negative angle. So my reference angle is here. That theta I'm going to find by doing trig, and I could do sine inverse or cos inverse, whatever I do, I'm going to pick my positive ratio, 5 over root 41. So there's my reference angle, it's positive. To get my actual theta, I'm going to do 2 pi, so I'm going to go a full circle and subtract the reference angle. So that's going to give me approximately, so 2 pi minus the answer, 5.39 radians. This takes a lot of practice to get comfortable with, knowing whether I'm adding the reference angle, subtracting the reference angle, and it's really being comfortable with the idea of 0, pi over 2, pi, 3 pi over 2, 2 pi. And I could keep going forever and ever.